Good day, everyone. I'm Christine Hart Bathan, mechanical engineering student from Colegio de Muntinlupa, and my topic is all about wind turbine and renewable energy. To start with the question of what is wind turbine? It is an alternatively referred to as a wind energy converter is a device that converts the wind's kinetic energy into electrical energy. This kinetic energy of a wind resource is not limited to convert into electrical energy, but also it can convert into mechanical work, such as pumping water, or it can be via mechanical work into electricity through a generator. There are three types of wind turbines, such as the vertical axis wind turbine or VAT, horizontal axis wind turbine or HOT, and conventional wind turbine. A vertical axis wind turbine have a main rotor shaft arranged vertically. One advantage of this arrangement is that the turbine does not need to be pointed into the wind to be affected, which is an advantage on a site where the wind direction is highly variable. Horizontal axis. While horizontal axis turbine is a large three-bladed horizontal axis wind turbine, with a blades upward of the tower produce the overwhelming majority of wind power in the world today. These turbines have the main rotor shaft and the electrical generator at the top of a tower and must be pointed into the wind. While unconventional wind turbine are those that differ significantly from the most common types in use, such as the vertical axis and horizontal axis wind turbine. Due to the large growth of the wind power industry, many wind turbine designs exist, and some unconventional designs have entered commercial use, while others have only been demonstrated or are only theoretical concepts. Unconventional designs cover a wide gamut of innovations, including different rotor types, basic functionalities, support structures, and form factors. And this what kind turbine looks like. These are the types of vertical axis, and vertical axis has four different structure of turbine. The first two are the Darius rotor vertical axis and helix vertical axis. The next two are the H. Darius vertical axis and Savonius vertical axis. They are different structures, but they all have set of blade that spins around a vertical axis. The next one is the horizontal axis. Horizontal axis has one permanent structure but differs from the number of blades. Like in the picture, one has 3 blades and the other one has multiple blades. However, it typically has 3-blade vertical propeller that catches the wind face on. The last type of turbine is the unconventional wind turbine. In this image, we can see that it all moves and when a system accelerates mass in one direction, the accelerated mass causes a proportional but opposite force on the system. The spinning blades causes a significant amount of rotational airflow. And there's a large turbine. So what is large turbine? A large turbine is a commonly deployed in large arrays of multiple turbines. Large turbines are also installed in distributed generation applications that consist of a single or a few turbines connected directly to a distribution line. It has rated capacity ranging from 660 kilowatts to 1,800 kilowatts or 1.8 megawatts and are designed for use in electricity generating power plants. Large turbines are typically deployed in wind farms and are intended to provide wholesale bulk electricity for production for delivery on the local transmission network. The higher the turbine and the capacity is, the longer its electricity can produce. The comparison of height between the two turbines with different height and the Statue of Liberty and the Empire State Building. On the other hand, there is small turbine. A small turbine can be a grid connected for residential or industrial electricity generation, or they can be used in off-grid applications such as pumping or battery charging. Small turbines are typically installed as a single unit or in a small numbers. The smallest turbines have a power rating less than 1 kilowatts. It is normally used to charge batteries for sailboats, cabins, and small homes. Turbines with power ratings between 1 kilowatts to 20 kilowatts are normally used for pumping water, small businesses, residential power, farm applications, remote communication stations, and government facilities. And the picture is just showing their height comparison. Why wind turbines are important? It is very important since they provide a way to produce electricity without causing pollution. Wind power is also a renewable resource. It is a great option than non-renewable resources such as coal and oil. Having this is a healthier option for us and for the earth. Renewable energy is a energy that is generated from natural processes that are continuously replenished. And according to 2019's Wind Powers America report, wind energy is their #1 renewable resource. It is a great option compared to non-renewable resources for the reason that the coal and oil are gone once they are used, only exist in limited supply on Earth, and can cause pollution. How wind turbines work. Wind turbines work on a simple principle. Instead of using electricity to make wind, turbines use wind to make electricity. It starts with turning the blades, then the blades turn the rotor, and the rotor turns the shaft. The shaft spins the generator, and the generator produces electricity. To surely understand, let's take a look at this. There's a wind flowing into the blades, and that wind will passes over the blades and makes them turn, and it is making a kinetic energy. And when it passes through the turbine, it creates mechanical energy. Followed by generator, which converts the mechanical energy from the turbine into electrical energy. Then goes into the transformer, where it converts the electricity to the right voltage for the local network. After that process, it goes into the distribution, where the electricity is being exported to the electricity grid. Lastly, you can able to use the electricity. The components of wind turbine. First is the rotor, which is approximately 20% of the wind turbine cost. Includes the blades for converting wind energy to low-speed rotational energy. Rotor is a moving component of an electromagnetic system in the electric motor. Its rotation is due to the interaction between the winding and magnetic fields, which produces a torque around the rotor's axis. Next is the generator, which is approximately 34% of the wind turbine cost. Includes the electrical generator, the control electronics, and most likely a gearbox, adjustable speed drive, or continuously variable transmission component for converting the low-speed incoming rotation to high-speed rotation suitable for generating electricity. Like what I have said earlier, generator is the one who converts the mechanical energy of the rotor to electrical energy. The surrounding structure is approximately 15% of the wind turbine cost, includes the tower and rotor yaw mechanism. And here's are the recent development in the technology. New designs, blade materials, glass and carbon fibers, hybrid reinforcements, nano-engineered polymers and composites, costs, non-blade materials, material supply recycling. Wind turbine rotor blades are being made longer to increase efficiency. This requires them to be stiff, strong, light, and resistant to fatigue. Materials with these properties are composites, such as a polyester and epoxy, while glass fiber and carbon fiber have been used for the reinforcing. Construction may use manual layup or injection molding. This technology needs to be developed or have an improvement in order for this to be more beneficial to the people, and it says that wind turbines are 50 times more powerful than 20 years ago. Again, this is Christine Hart Bathan, mechanical engineering student from Colegio de Muntinlupa.